Hello, this is a session on simple linear regression. I am Dr. Karthikeya Bola. Okay. We'll straight away go to a problem. So this is a data regarding a company's yearly sales volume and its advertising expenditure over a period of 8 years. So you have sales in millions of dollars as one of the variables and advertising in $10,000 as another variable. Now, here we consider one of these variables as dependent variable and the other as the independent variable. See, we understand that by having more advertising, we'll get more exposure and thereby it may enhance sales. So hence we can say that the more the expenditure in advertisement, we can expect higher sales, or in other words, the sales might be dependent upon how much advertisement expenditure happens. Okay, so advertising expenditure can become an independent variable, whereas sales will become the dependent variable. Okay, now in a simple linear regression, we are expecting that the relationship between the dependent variable and an independent variable has to be linear. That means y, that is sales, is a linear equation in terms of x. That means it's a linear function in terms of x. Okay, so when we say linear equation, and since here there is only one independent variable, that's why it is called simple linear regression. Okay, so it would be of a form of y equal to a plus bx. Okay, so the first step is to get the estimated line equation wherein y, that is the dependent variable, is a line equation in terms of x, that is y is equal to a plus bx. So given the data set y and x, you should be able to find out the parameters of this equation, that is a and b. Now, from the data, we can calculate a and b as follows. Now, b is sxy divided by sxx. So what it means is, if you go back to the data, first you get the mean of the corresponding variables, okay, right, and then you find out the difference of the individual variables from their corresponding mean. So this is what we mean by x here, right? So when we say sxx, it means it is a summation, okay? It is a summation of the square of the differences of individual variables from their mean. Alright? Similarly, when we say sxy, it is the summation of the product of the differences of x from the mean and y from the mean. That means the individual values of x from the mean x and individual values of y from the mean y. That is, you can say as xi minus x bar and yi minus y bar. You multiply the individual values, then sum them up. That is sxy. Okay, so once we get these results, we can get the value of b. Okay, now when we say a regression line or the line equation, what we are suggesting is that the overall average of the differences of the observed values from the line is equal to 0. So what it means is that the combination of x bar and y bar should be on the regression line. That means the coordinate of x bar and y bar has to lie on the line equation. Okay, so hence we can find out the value of a by just replacing y and x with y bar and x bar. So hence you get a equal to y bar minus b into x bar. Moving to the next step, once we get the line equation, we need to check for the significance of that line equation or the model or the function. Okay, now the corresponding set of hypotheses of null and alternative hypothesis is as follows. When we say significance of the model, we are saying that the coefficients of the parameters, coefficient or the parameters should be different from 0. Okay, that means there should be an existence of a line equation. So when we say the model is significant, there should be an existence of the line equation. Okay, now in this case I got the summary output when we ran a regression over y and x of the above problem, and then we got b value of b as 0.789, whereas the value of a as minus 10.42. Now these two are called the regression coefficients of the line. So the intercept and the coefficient of x, they are called the regression coefficients of the line, right? So now we need to check that whether this particular equation is significant or not. So how do we check that? Now we have a ANOVA table corresponding to regression. Now in this ANOVA table, we have two parts. Basically the two parts, one talking about regression and the other talking about the residual. Now regression part is something which talks more about the model. That means something where there is an explanation for the model. Residual is that particular part which is not explained by the model. Naturally, when we expect the model to be significant, we should emphasize on the explanation part rather than the unexplained part. So what we really want to see is how much is the explanation part, okay, has an effect corresponding to the unexplained part. Now, if you see, there are degrees of freedom mentioned, sum of squares mentioned, mean sum of squares mentioned, and the F statistic mentioned there. Now, how all these are calculated? Okay. Now, if you see, there is something called as total sum of squares, which is given as 56. Okay. Now, this particular value is got by the overall change in y from its mean. So it is nothing but sigma yi minus y bar the whole square. Now this particular total sum of squares is divided into two. There is something called as regression sum of squares and something as residual sum of squares. Now when we say residual sum of squares, what it means is that we find out the difference of the observed values, right, from the estimated values, and then find out the difference and square that difference. So when we say estimate, we refer to those values which are got by applying the line equation. So when we say line equation, it is actually an estimated line equation, okay, from where given some input values for x, you can get the y estimates. So 8.63 is the result of summation of all those square of differences between the observed value of y and the estimated value of y, which comes from the equation. So you can get the regression sum of squares by taking the difference from the total sum of squares of the residual sum of squares. Similarly, when it comes to degrees of freedom, the regression degrees of freedom refers to the number of independent variables. So in this case, there is one independent variable, so hence degrees of freedom corresponding to regression is 1. When it comes to the total degrees of freedom, it's basically the total number of observations minus 1. That means total number of observations. So since here in this particular problem we had 8 observations, so the degrees of freedom for total is 7. Now the corresponding mean sum of squares are got from dividing total sum of squares corresponding to regression and residual divided by their corresponding degrees of freedom. Now the F statistic which we get is nothing but the ratio of mean sum of squares regression upon mean sum of squares residual. Okay, so this is the F statistic which we will check for the significance of the model. So as I said, the model is significant when it explains most of the part. That means the regression mean sum of squares should overshadow the residual sum of squares if the model has to be significant. That means you will expect a high value of f when the model is significant compared to the critical value of f which we get from the table. Now there is a p-value mentioned as significance f. Now this itself also indicates that the very low value of the significance f means that the model is significant. So hence here we can say that this particular data set, if we assume a linear relationship, we are not doing any kind of mistake here. Okay, so the value of f statistic is greater than f critical, or the significance f is very small compared to alpha if we take as 0.05. okay, then we can say that there is enough evidence to reject the null hypothesis, and hence alternate hypothesis may be accepted. Okay, but then there is another table. If you see that there is a T-Statistic table down. Now that particular table is redundant in the case of simple linear regression because it will give the same results as of the F. Okay, as you see here that